Did you know that a typical house wastes 30% more electricity than an efficient house? There's a need to build a system to mitigate these losses, thanks to deep learning, which gives promising results in data forecasting. This can be used to predict power consumption, to plan and regularize these losses. This is what our project exactly does. We have used CNN and RNN modules that forecast the power consumption.
We acquired the dataset from UCI repository. It consists of power consumption of household from December 2006 to November 2010. It is a multivariate dataset with 7 parameters: global active power, global reactive power, intensity, voltage, sum metering 1 for kitchen, sum metering 2 for laundry, sum metering 3 for climatic control devices. Since it is a raw dataset, it requires preprocessing. We first replaced with the missing values with NaN values. These NaN values are then identified and replaced with previous day values. These miscellaneous power values are calculated and stored as sum metering 4, which becomes the 8th parameter.
After pre-processing, the dataset is imported as a CSV file. It is then split into training and testing. The first 1114 rows is provided for training and the last 328 rows is given for testing. To arrange the dataset in correct weekly format, we excluded the first row of training and last 6 rows of testing. The dataset is now ready to be fed into the model. We created 2 layers. The first layer with 32 filters and the next layer with 16 filters. For both layers, we used activation function as ReLU. The kernel size of the second layer is 3. We added a max pooling to the second layer with a pool size of 2. The value from these layers is passed into the densely connected layers of 100 nodes and with the same activation function as ReLU. We used Adam optimizer for the model as it provides high accuracy than other optimizers.
Since CNN had certain limitations like fixed window size, we further enhanced our model by using recurrent neural network. RN is generally efficient in time series data because it also keeps track record of process. We used LSTM model of 200 nodes and used activation function as ReLU. It was then passed into a densely connected layer of 100 nodes. The loss function is mean square error and optimizer is Adam. We trained the model by providing 100 epochs and batch size is taken as 16. We plotted the loss and total power consumption for the same and results are as follows. So after all, it is observed that the RN model produces more precise forecast than a CNN model. It is evidence from the graph. For time series data, the best model is used is LSTM model.
The final stage of this project is deployment. We saved the model and created files in HPy and JSON formats. We first deployed it as a window application. We built a button using ticking tab which when clicked predicts the value for next 7 days. We also built a web page which interprets the power consumption for the next 7 days and displays it as a graph. The future enhancement would be deploying it as an Android application.